Chemistry is the science that explores the materials and substances that make up our world. It studies how these materials interact, combine, and change. At its core, chemistry seeks to answer the question, what is everything made of? This branch of science is fundamental because it connects other sciences like biology and physics. Imagine chemistry as a puzzle. Each piece represents a tiny part of the universe, fitting together in countless ways to create everything we see. From the air we breathe to the stars in the sky, chemistry is at work. It helps us understand the composition of the universe and the processes that govern the natural world. The journey into chemistry offers endless possibilities and discoveries. It is like unraveling the secrets of a vast library, where each book is a different substance with its own story. Whether you're curious about why leaves change color or how batteries power your devices, chemistry has the answers. Chemistry isn't just for scientists in lab coats, it's for everyone who wonders about the world around them. By understanding chemistry, you can see the magic that surrounds us every day. So let's dive into the fascinating world of chemistry and discover its wonders. At the heart of chemistry are atoms, the smallest units of matter. Think of atoms as the building blocks of everything. They are incredibly tiny, so small that millions could fit on the head of a pin. Atoms consist of a nucleus made of protons and neutrons surrounded by electrons. Molecules are formed when two or more atoms bond together. For example, a water molecule is made of 2 hydrogen atoms and 1 oxygen atom, written as H2O. Molecules can be simple, like oxygen gas, O2, or complex, like proteins in our bodies. They make up all the substances we encounter. Elements are pure substances that consist of only one type of atom. There are 118 known elements, each with unique properties. These elements are like the letters of an alphabet, combining in various ways to form the words in the language of chemistry. Common elements include hydrogen, carbon, and gold. Understanding these basic building blocks is essential for grasping more complex chemical concepts. Atoms, molecules, and elements are the foundation upon which all chemistry is built. They hold the keys to unlocking the mysteries of matter and energy. Compounds are substances formed when 2 or more elements chemically bond together. Unlike a mixture where substances are combined physically, compounds have unique chemical properties. For example, table salt is a compound made of sodium and chlorine, which are both dangerous alone but safe when combined. Chemical bonds hold compounds together. There are various types of bonds, such as ionic and covalent bonds. In an ionic bond, one atom donates an electron to another, creating charged ions that attract each other. In a covalent bond, atoms share electrons. These interactions determine the compound's properties. Water is a perfect example of a compound. It is essential for life and has unique properties due to the hydrogen and oxygen atoms that form it. The strong hydrogen bonds between water molecules give it a high boiling point and make it a good solvent, which is why it can dissolve so many substances. Learning about compounds helps us understand how elements can transform into entirely new substances. It allows us to create everything from medicines to materials. By mastering the art of combining elements, we unlock the potential to innovate and solve problems. The periodic table is a chart that organizes all known elements based on their properties. It was created by Dmitri Mendeleev in 1869 and has evolved over time. This table is a powerful tool for chemists, providing valuable information about each element at a glance. Each element on the periodic table has a unique atomic number, which represents the number of protons in an atom's nucleus. Elements are arranged in rows called periods and columns known as groups. Elements in the same group often share similar chemical properties. The periodic table also reveals patterns, such as trends in atomic size, electronegativity, and reactivity. For instance, noble gases like helium and neon are found in the far right column and are known for being inert, meaning they don't easily form compounds with other elements. Understanding the periodic table is like learning the rules of a complex game. It guides chemists as they predict how elements will behave and interact. This knowledge is crucial for everything from developing new materials to understanding biological processes. Section 5. Chemistry in the kitchen. Chemistry is all around us, and the kitchen is a perfect example of where it comes to life. Cooking is essentially a series of chemical reactions that transform raw ingredients into delicious dishes. When you bake a cake, the heat causes the baking powder to produce carbon dioxide gas, making the cake rise. Another example is the Maillard reaction, which occurs when proteins and sugars in food are exposed to heat, resulting in browning and flavor development. This is what gives grilled meats and roasted coffee their distinctive tastes. Chemistry explains why eggs solidify when cooked and why vinegar can tenderize meat. Even the preservation of food involves chemistry. Pickling, for instance, uses acetic acid from vinegar to kill bacteria and extend shelf life. Understanding these processes helps us improve flavors, textures, and nutritional value, making cooking both an art and a science. Chemistry in the kitchen shows how scientific principles apply to everyday tasks. It enhances our culinary skills and deepens our appreciation for the food we eat. Whether you're a gourmet chef or a home cook, chemistry is your ally in creating culinary masterpieces. Section 6. Chemistry in medicine. Chemistry plays a vital role in medicine, contributing to the development of drugs and treatments that save lives. Pharmaceuticals are essentially chemical compounds designed to interact with the body in specific ways to treat illnesses. From aspirin to antibiotics, chemistry is at the heart of modern medicine. The process of drug discovery involves understanding how different compounds affect biological systems. Chemists study the interactions at the molecular level to design effective and safe medications. For example, the development of penicillin revolutionized the treatment of bacterial infections. Chemistry also aids in diagnostic processes. Techniques like blood tests and imaging rely on chemical principles to detect disease. Radiopharmaceuticals, which are radioactive chemicals used in medical imaging, help diagnose and monitor conditions like cancer. The innovative power of chemistry continues to drive medical advances. It holds the promise of new treatments and cures, improving the quality of life for people worldwide. The intersection of chemistry and medicine exemplifies how science can transform health and well-being. Section 7. Chemistry and technology. The field of technology is another area where chemistry makes significant contributions. From the materials used in electronic devices to the development of new energy sources, chemistry is at the forefront of technological innovation. Semiconductors, essential components of electronic devices, are made possible through chemistry. Silicon, a key element in semiconductors, is chemically processed to create chips that power computers and smartphones. Chemistry also plays a role in developing plastics, polymers, and other materials used in technology. In the realm of energy, chemistry is crucial in the development of batteries and renewable energy sources. Lithium-ion batteries, which power everything from laptops to electric cars, rely on chemical reactions to store and release energy. Advances in chemistry are paving the way for more efficient and sustainable energy solutions. The impact of chemistry on technology highlights its importance in driving progress. As new challenges arise, chemistry will continue to be a key player in developing innovative solutions that enhance our technological capabilities. Section 8. Fun facts to amaze. Chemistry is full of fascinating facts that can spark curiosity and wonder. Did you know that honey never spoils? Archaeologists have found pots of honey in ancient Egyptian tombs that are over 3,000 years old and still edible, thanks to honey's unique chemical composition. Another intriguing fact is that diamonds and graphite, two very different substances, are both made of carbon. The difference lies in how the carbon atoms are arranged. In diamonds, the atoms form a strong three-dimensional lattice, while in graphite, they form layers that slide over each other. The smell of rain, known as petrichor, is another chemical phenomenon. It's caused by oils released from plants and a compound called geosmin, produced by soil bacteria. This combination creates the fresh, earthy scent we associate with rain. These fun facts illustrate the diverse and intriguing nature of chemistry. They remind us that chemistry isn't just a subject to study, it's a source of endless amazement and exploration. Section 9. The future and importance of chemistry. The future of chemistry is bright and full of possibilities. As we face global challenges like climate change and resource scarcity, chemistry offers tools and knowledge to develop sustainable solutions. It is essential for creating new materials, medicines, and technologies that improve our lives. Chemistry also opens doors to diverse career opportunities. From research and development to education and environmental science, chemists play crucial roles in various fields. Their work impacts industries, healthcare, and the environment, making a difference on multiple levels. Understanding chemistry empowers us to make informed decisions about the world around us. It fosters innovation and creativity, encouraging us to explore new frontiers. Whether it's developing cleaner energy or discovering life-saving drugs, chemistry will continue to shape our future. Embracing the wonders of chemistry inspires curiosity and a lifelong love of learning. It invites us to explore the universe at the molecular level, revealing the beauty and complexity of the world we inhabit. Chemistry is not just a science, it's a pathway to a better tomorrow.